Good morning, everyone. Welcome back. Thank you for joining us. Glad you're here. I'm Steve.
And I'm Scott.
And together we're Backyard Musings, Science and Technology Channel.
Yep. And we are talking about a skeleton today, but not in the normal sense that you would think. So here we go.
The sharpest dark matter map ever reveals the invisible cosmic scaffolding that built galaxies, stars, and ultimately life itself. Scientists have produced the most detailed map ever created of dark matter across the universe, revealing how this unseen substance has shaped the formation of stars, galaxies, and planets. Would you like to know more?
The work, which includes astronomers from Durham University in the United Kingdom, sheds new light on how dark matter helped gather ordinary matter into massive structures such as the Milky Way and even laid the groundwork for planets like Earth. Okay, but we know the creator here. So the results are based on new observations from NASA's James Webb Space Telescope. We love that, and have been published January 26th, 2026, just a couple days ago, in the journal Nature Astronomy. The international study was jointly led by Durham University, NASA's Jet Propulsion Laboratory in Pasadena, California, whoop whoop, and the, I don't know how to go, is this École Polytechnique Fédérale de Lausanne in Switzerland, I guess. It sounds French.
It sounds French to me, you know what I'm saying?
Yeah.
All right, so this slide that you're seeing, this map shows the dark matter distribution in the cosmos field observed by the Hubble Space Telescope on the left and the James Webb Space Telescope on the right. Dark matter distribution in the cosmos field. The overlaid contours mark regions of equal dark matter density, highlighting where this invisible matter, shown here in a blue color, is most strongly concentrated.
So what are we trying to see here? Are we trying to see that one telescope is a little bit more powerful, I guess you could say, than the other? Or are they just getting different views?
Well, that's the first observation. One is more powerful, but if you look besides the blue, you look at the other areas, James Webb is picking up a little bit more.
And it's farther out, though, right?
Yeah, Hubble is right around the in orbit of the Earth. Yeah.
Yeah.
Might be cutting out noise.
So maybe the Hubble is actually more powerful then. If it's not as close. And
there's more detail. More detail on the Webb Space Telescope.
Yeah. The newly created map supports earlier findings while offering much finer detail about how dark matter interacts with the normal matter that makes up everything we can see and touch. In the early universe, both dark matter and normal matter were likely spread thinly across space. Scientists believe dark matter began clumping together first, forming gravitational wells that drew in ordinary matter. These dense regions eventually became the birthplaces of stars and galaxies.
That's pretty interesting.
Yeah.
This process helped determine the large-scale arrangement of galaxies seen across the universe today. By jump-starting the formation of stars and galaxies earlier than would otherwise have been possible, dark matter also helped create the conditions needed for planets to form. Without this early influence, the elements necessary for life may never have developed within our galaxy.
Okay, so we got slide. Yeah, there we go. Research co-lead author Dr. Gavin Leroy in the Institute for Computational Cosmology, Department of Physics, Durham University, said, by revealing dark matter with unprecedented precision, our map shows how an invisible component of the universe has structured visible matter to the point of enabling the emergence of galaxies, stars, and ultimately life itself.
Dark matter cannot be seen directly because it does not emit, reflect, absorb, or block light. Well, do you need your special Ray-Ban glasses to see this thing? It also passes through ordinary matter without interaction, much like a ghost. I don't know if that's been proven, though. Has it been proven that ghosts pass through things?
I don't know. Ask Casper, I guess.
Its presence is revealed instead through gravity. The new map captures this effect with far greater clarity than before. So this, I mean, they're calling it dark matter, but it might be something else if it can't be seen or detected except by gravity. Scientists found that regions rich in dark matter closely map the locations of normal matter, a pattern that cannot be explained by chance.
It almost looks like a negative topographical map.
Yeah, yeah.
Really interesting the way the lines are and everything. So, according to the research team, Webb's observations confirm that dark matter's gravity has been steadily pulling ordinary matter toward it throughout cosmic history.
So it must be denser. It must, in order to pull stuff, it's got to be denser. Research co-author Professor Richard Massey in the Institute for Computational Cosmology, Department of Physics, Durham University said, wherever you find normal matter in the universe today, you'll also find dark matter.
The new map covers a patch of sky about 2.5 times the size of the full moon, located in the constellation Sextans, spelled Sextans. Webb observed this region for roughly 255 hours. It's kind of a weird amount of time, identifying nearly 800,000 galaxies.
That's a lot.
That is a lot. Without number, right?
Yeah.
Many of which have been never seen before. To locate dark matter, the team measured how its mass warps space itself, causing light from the distant galaxies to bend as it travels towards Earth, similar to looking through distorted glass.
I wonder if it's like looking through water and the fish, you think the fish is here, but the fish is over here because of
the refraction or whatever they call
it. I wonder. This map includes around 10 times more galaxies than previously ground-based surveys of the same area and twice as many as those observed by the Hubble Space Telescope. It reveals previously unknown concentrations of dark matter and shows known regions in much sharper detail.
To improve distance measurements for many galaxies in the map, the researchers relied on Webb's Mid-Infrared Instrument, or MIRI. Durham University's Center for Extragalactic Astronomy, that sounds kind of cool, contributed to the development of MIRI, which was designed and managed through the launch by JPL. The instrument is especially effective at detecting galaxies hidden behind thick clouds of cosmic dust. We just talked about cosmic dust, right? Gas and dust that was...
Yep. That big thing, the cloud that went in front of that star.
Yeah, that sun. So
next, cool. The team plans to expand their work by mapping dark matter across the entire universe using the European Space Agency's Euclid telescope and NASA's upcoming Nancy Grace Roman Space Telescope. Nancy Grace?
That's an interesting.
Interesting
name.
She's like the defense attorney that's on TV breaking down the criminal law.
You think maybe it's a different Nancy Grace?
I don't know, man. It's not like that name's common, like there's a dozen Nancy Graces out there.
Okay, we'll have to do some research on that one.
Okay, Nancy Grace Roman Space Telescope. These not roaming, Roman, ROMAN.
Yeah.
These missions will help scientists better understand dark matter's basic properties and how it may have evolved over time.
The region studied in its latest research will serve as a benchmark, providing a reference point for all future dark matter maps and comparisons. So, you've seen it here.
Yeah, I mean, I found out something I didn't know,
Yeah, Nancy Grace has got her own telescope. Pretty cool. And it's Roman. I wonder why it's not some other brand.
Just to give you a perspective, when I was in 7th grade, I had a language arts teacher who, instead of saying linking verb, a verb that links something, she would say Lincoln verb. And I had this picture of Abraham Lincoln all throughout my life until my wife finally broke it down. My wife is an English teacher and said, no, it's linking verb. So I was traumatized just because of some syntax.
Involving Abraham Lincoln. All right.
All right, folks. Thanks for joining us. We'll catch you in the afternoon.
See you this afternoon. Thanks for listening.